Okay, so I think, guys, that we know how to do everything on here, just without me explaining much to you. Basically, we're just given a different amount of information than we were given before. Like before, we were given the point. We kind of had to work with that to put together our triangle. Um, Here, what it's asking you to do, it says find each of the remaining trig functions, right? So it's giving us one, and we need to find the other five. Okay. So just thinking about that. So we got sine, it's telling us cosine, negative 3/5, and then we need to find the rest here. Um, we have that. We are going to end up drawing this too, so we can get our graph. Okay, now here's my question for you guys, is if we're figuring this out ourselves, we're given cosine, this value. And we're told that theta, or our angle, our terminal side of our angle, is going to end up here in quadrant 3. Okay, so just those two bits of information are going to be enough for me to uh, get the rest of my trig functions filled out. Okay, and this is what I want you guys to think about. Just take 2 or 3 minutes even. And if you don't get it, we'll go over it together in those 2 or 3 minutes. But how can you use this cosine value, and how can you use the fact that it's in quadrant 3 to kind of put the rest of it together? Okay, so just think about that for yourself. The last bit I'll tell you here is that, again, thinking about because what we need to put together our trig functions is an x value and a y value from our point, and then the radius or the hypotenuse. Okay, and when it tells me cosine, that's actually giving me 2 out of those 3 values. Like you can say, okay, I know what 2 of those letters are just based on this. Okay, so just think about that. Take 2 or 3 minutes. Um, Try to kind of piece the rest of this together just based on that. Okay. All right, guys. So somebody explain to me, like, what can you take from just these two pieces of information? What can you use that for to kind of help figure out the rest? Right. Yeah. So -3 and +5 are going to be my x value and my r value. Now you might be wondering too, like you see up here the cosine, it says -3/5 with like the negative sign right next to your fraction. So you might be thinking like, how do you know that the negative goes with the 3? And both of them aren't negative, right? If it was a negative over a negative, that would equal a positive, right? But, and this is just something, just a rule too, that our radius, and how we've drawn the triangles too, this has been true. The radius is always going to be positive. Okay. So like if you're given a fraction that involves the radius that's negative, you can just put that value with the other number. Okay. So that's just a good thing to know. Okay. So the radius is always positive, which makes x -3. Okay. And what else can you gather from that? Um, and I mentioned up here, like the x value being negative, and if it's in quadrant 3, that means the y value also has to be negative. And that's really important to do, kind of figure out that first, because using the Pythagorean theorem to find y, it can be a little bit confusing whether your answer is going to end up being positive or negative. But yeah, because like if it's a point in quadrant 3, I know it's going to be like down, you don't have to be super exact with it, but like it's going to be somewhere in quadrant 3. So there's your triangle, right? And just from given the cosine, I know this is going to be -3, and I know that radius or hypotenuse is 5. So really the only thing I'm missing then would be this other side, right? That y value. And like I know too that the coordinates of this point would be -3 comma something. Okay. And the fact that it's in quadrant 3 tells me that it's going to be negative something. Okay. And so then, like I said, we put together our Pythagorean theorem and solve for that missing value, right? So it'd be -3 squared plus b squared equals 5 squared, right? And then just kind of work it out. We did something like this before, right? So 9 plus b squared equals 25. Subtract 9, b squared equals 16. And then here's where it gets tricky, right? Because like just solving a Pythagorean theorem problem without the context of a triangle at all, like here, when you take the square root of both sides, just in an algebra problem, typically you'd say b equals positive or -4. Okay. Like if just in any algebra problem, if you do something squared equals something, taking the square root. Because think about it, -4 squared would be 16. and positive 4 squared would be 16. So that's why we include both. But at the beginning of the unit, I did say, like, hey, most of the time with right triangles, we kind of don't really count the negative answer because side lengths can't be negative. And that's still true. But now that we're thinking of it in the context of a graph, this value can be negative, right? This y value. And I know that it is going to be negative, like we said, because it's in quadrant 3. So we are going to say this answer is negative 4, again, because we knew it was negative from before we even started. Okay, so, and then once I find that third value, now I know all that I need to fill in the rest of this. Okay, so yeah, sines y over r, right? So that would just be negative 4 over 5. Tangent is y over x. That would be negative 4 over negative 3. And again, a negative over negative is positive. So just write positive 4/3. And then just flip them all around for my reciprocal functions here. And then, yeah, you could also, once you know all 3 side lengths, or even just 2 of the side lengths, you could find the angles on the inside if it asks you to do that. But it doesn't here. It doesn't ask you to do that. Okay. So, yeah. Oh, and then, yeah, this point would have negative 3, negative 4 would be the coordinates. But, all right. How do we feel, guys? You can do that yourself, you think? Hopefully. Yeah. So why don't you do 27 here? Okay, if you can start that if you haven't. Just the one thing that's different, right, is this second statement. It's telling you the cosine again, but it's saying this. Anybody know what this, like, how could we use that to help us? It pertains to, like, the quadrants. That's saying it's kind of the angles between 270 and 360. So does anybody know what quadrant would that tie in with? Think about your graph and think about like a 270-degree angle and like a 360-degree angle. Any ideas? Yeah. Quadrant 4, yeah, you think about this, yeah. So it's like starting from here, a 270-degree angle would be about a 3/4 turn and take you to about there. And then a 360-degree angle would kind of take you the rest of the way, right? So if it's between 270 and 360, yeah, it's got to be kind of in that quadrant 4. Okay, so that's what that's telling you. Okay. And also, once you figure out what quadrant it's in, the moment that you do that, think like, okay, what are the coordinates of the points in there, right? And that would be that the x values are positive, the y values are negative. Okay, so again, when you do the Pythagorean theorem to find the missing value, you know exactly what your signs are supposed to be. Okay. All right. What did you guys find for, like, so we use 8 and 17, just like the last one, right? 8 is my x value, 17 is my r value, and then for y, we found what? What would be our y? Negative 15. Awesome. Yeah, you do your Pythagorean theorem, right? 8 squared plus b squared equals 17 squared. That's 64 equals 289, right? And you subtract, and it's b squared equals 225. You take the square root, and again, by knowing that this point is in quadrant 4, we know that our y value, our missing value, has to be negative. Okay, so we think of that as being negative 15. And again, that also means that the location of that point that the triangle ends at would be also 8 comma negative 15. Okay, so just good stuff to know. And then, yeah, going into that for my trig functions, just putting them all together. Okay, so we're good. You guys did awesome with that. And so we are ready. Our last one here. Yeah, let's figure out what all this means. Same problem, same directions, but yeah, definitely more confusing with what it gives us. Okay, so still finding our 6 trig functions. And so we are given secant is negative 3. Okay. Okay. Now, the only issue with that is that, again, these are all trig ratios, meaning that these are all fractions. Okay. So secant being negative 3, this is like the simplified version of a fraction. And so you might immediately think, oh, negative 3 is a fraction, so you might think negative 3 over 1. That's actually not what it is, okay? Because think about this. Secant is the reciprocal of cosine, right? Cosine, we said, was x over r, which makes secant what? R over x, right? Just flip it. And so think about this. If we said -3 over 1, we'd be saying that the radius was -3. And we said at the beginning, the radius is never going to be, it's always going to be positive, okay? So that wouldn't work, okay? Which means what? I have to write it a different way. And really the only other different way to write it would just be 3 over -1, right? That would also equal -3, and my radius would be positive. Does that make sense? So just can't have a negative radius. So that's my secant. I can flip that around. -1 over 3 would be my cosine, okay? And then same idea. I can just fill those numbers in. My radius is 3. My x value is -1, okay? And then same idea. You use that to fill in your y value with the Pythagorean theorem. But something else that we need to know too is, right, that's just from this statement right here. We haven't really brought in this one yet. Now, how is this helpful? This is a fancy way of saying tangent is positive, right? Tangent greater than 0. So tangent's positive. Now, how does that help us figure out specifically like the quadrant? Mm-hmm.
You can find what quadrant the point will be in.
Sure. Yeah, absolutely. Yeah. So we can do that, right? And unfortunately, this one doesn't end up being like a whole number like the last one. But yeah, we could do Pythagorean theorem. We can find kind of that value. The only part that's tricky though too is that like when we do Pythagorean theorem, right, we're going to be it's going to be the same as these other ones, right? We're going to be setting up our numbers, squaring them, subtracting. And then when we take the square root at the end, right, our answer would be positive or negative, whatever number it is, right? And so we kind of have to know ahead of time whether it's going to be the positive or negative version of that number, okay? And so there's a couple of ways that we can know ahead of time whether that y value is going to be positive or negative. Anybody have any guesses at that, or what can we use? Knowing what we know now, how do we know what quadrant it would be in? Yeah, so we know, and you're thinking of your of this here. You remember in your yeah. So guys, you remember this acronym we went over a couple days ago, right? All students take calculus, and this is also telling you in which quadrants each of the trig functions that are going to be positive, or like so in the first quadrant here, all the trig functions are positive. In the second quadrant, just sine is positive. In the third quadrant, just tangent's positive. In the fourth quadrant, just cosine. So how this is helpful is, right, if we're told that tangent's positive, right, I know that it definitely can't be in quadrant 2, because in quadrant 2, just sine is positive. I know it definitely can't be in quadrant 4, because in there, just cosine's positive. So it could be in either the first one, because all the ones are positive in quadrant 1, or in quadrant 3, where just tangent is. And knowing how do you know that it's going to be, definitely in quadrant 3 instead of quadrant 1?
So that when it's divided by -1, the answer is positive.
Exactly. Yeah, that's a good, so we know, right, because tangent's y over x, right, and x is negative, right? If x is negative, the only way that we can get a positive tangent answer from dividing by a negative is if y is also negative, okay? The other way that you could figure it out too is just thinking about your points, right? If x was negative, none of the x values in quadrant 1 are negative, right? In quadrant 1, all the x values, all the numbers are positive, x and y. So that's how you know it's not going to be in quadrant 1 either. It's because if x is -1, cannot be in quadrant 1. Okay, so using that kind of process of elimination, we know that this is going to be in quadrant 3. Okay, and so we can move forward with that. Okay. And again, what does that tell us? That it's in quadrant 3. Again, where my signs are both negative in quadrant 3, I know then all that just told us that the y value is going to be negative when I go to, after I do my Pythagorean theorem. Okay, so that's why it's helpful to know for that. Okay, And then did anybody use the Pythagorean theorem and find their value for that? If you didn't, we can just work it out here. I do want you guys to do this one because it doesn't work out as nicely. It's not a whole number. So, right, we got our x value is -1. We don't know our y value, but our radius or our hypotenuse is 3. So it would be -1 squared plus b squared equals 3 squared. And so that would be 1 plus b squared equals 9. And then go from there and think about, so how would we write b? Yeah, and it's negative as well, right? So we subtract, so 9 minus 1 is 8, and we take the square root, so we would write negative square root of 8, right? Knowing that it's negative from being in quadrant 3. The other way, guys, and again, I'm not being super picky with this, but I'm just telling you, like ACT, SAT, like when you would go to do this stuff, you probably would be expected to take this next step of simplifying this radical, which would be writing -2 square root of 2, right? Because 8 has, right, again, how to go about that? 8 has a perfect square factor of 4, right? So really simplifying radicals is just knowing your perfect squares. And the square root of 4 is just 2, right? So that's just quick summary there of, but again, on a test, for me, you would not be like, I won't take off any points if you just leave it as this. Okay. But just know that the proper thing to do when leaving it in radical form is simplifying it, taking that next step. Okay. All right. So I'll just write all these answers with negative square root of 8 in there. Very good. How do we feel, guys? Does that make sense? I love it. Yeah, and then let's just fill all these in. So negative square root of 8 over 3, -1 over 3, negative square root of 8 over -1, negative over negative is a positive, and that's just over 1. So, and then, yeah. And then also a good thing to do would be to rationalize the denominator for these, but again, I'm not going to be too picky about that on this test. Okay. Any questions? Anything confusing? Okay.